All right? Should we go and do now? Yes. It was what? Manganese 1 plus? Well, then you will have to have 4s1. Okay, so you will put, then you will have an S here with 1 electron. Now, that means that you will have now 6 unpaired electrons, right? If it was that the case, right? No, wait a minute. What am I saying? You said manganese plus 1? Okay, that means you remove only 1 electron. No, that's correct. Yeah, okay. Okay, let's do this problem. What's that? We'll do it later. Okay, so this is a good problem. So let's see what we have. We have the mass. You probably don't like the color of the pen, huh? But you like the blue more. Oh, let me see if I have the blue one. I'm not sure. No. I changed my bag and I don't have the things that I need. Wait a minute. I think I do. Yeah, I do. Okay, good. Oh, I have a pointer too. Whoa. The battery's gone. It's the old one. Oh, red. Okay, so we have the mass equal to 18.2 grams. That's the mass of a monoprotic acid. Okay, monoprotic acid, that means we have 1 hydrogen ionizable, and we can put it, because it's always the positive part, we can put HA. That's the general type, right? A is the anion, stands for the anion, and monoprotic means 1 hydrogen ionizable. Doesn't mean that it has only 1 hydrogen, it can have more than 1, but 1 is ionizable. So the general formula of a monoprotic acid will be like this. A is anion, big, small, we don't care. So we have so many grams of this monoprotic acid in, this grams is in 5 liters. In 5 liters. So we have, so this is equivalent actually to say we have 18.2 grams of HA per 5 liters of solution. And the concentration of the acid is concentration of HA, brackets means molarity, always by definition. So the concentration, the molarity of this acid in this solution, that we have so many grams of the acid per so many liters of solution, is 1/10 of a molar, 0.10 moles per liter. And the question is, what is the monoprotic acid? That means we need to know actually what A is. Isn't that right? If it says what is the monoprotic acid, is it acetic acid, hydrochloric acid, hydrobromic acid? What is it? Right? It's monoprotic. So we want to find out actually A is equal to what? What is A? That's what the problem is asking us, right? Okay, so one way, if you have seen these problems before, is if you find the molecular mass. Oh, there you are. Welcome. Hey, here's our musicians. Welcome. We're in about 2 or 3 minutes ready. So if we find the molecular mass, the mass of the molecule, or the molar mass, which is arithmetically equal, right, of this species, then hydrogen is 1. If we know the whole thing, we can find out A, how much is the molecular mass, so probably something that will be kind of familiar to us, right? You see that? We want to find the identity of the acid. We know this is 1. If we find how many, what number is that? Probably it might be something in the periodic table, 1 atom, 1 ion, right? Like chloride ion, or Br minus, or something like that. That's what the thought is, right? Okay. So how are we going to solve this now problem? Let's see. What do we know? We know the molarity and we know the volume, right? Molarity and volume. Here is the molarity and here is the volume. What do we know by these two? If you know molarity and volume, you remember that molarity times volume, if the volume is in liters, that gives us that. You get the number of moles, right? Molarity is almost moles per liter. If the volume is in liters, you get the number of moles. So that means that we can know the number of moles. We have 0.10 moles of the acid HA per 1 liter of solution times 5 liters of solution. That will give you 0.50 moles of HA. Okay, so we know how many moles. Okay, if we know how many moles, and we have the mass, how do these two things relate? That's what you think, right? You know the number of moles, you have the mass. Does that relate to something that you will use to find out what the problem is asking? Remember, number of moles, right? Besides the fact that it's equal to molarity times the volume of the solution, is also equal to what? Mass divided by molar mass. You see, these two equations are very important, right? So this is in grams, and this is in grams per mole. And this is, of course, going to be moles. So these two equations are very important. Molarity times volume, volume in liters gives you moles. And the number of moles is always mass divided by the molar mass. Grams per mole, that will give you moles. Right? And that gives you moles. So, we know the number of moles, we know the mass, and we can find out the molar mass. So, molar mass then is going to be equal to, molar mass is going to be equal to mass divided by the number of moles, so it's going to be 18.2 grams divided by 0.50 moles is equal to 36.4 grams per mole. Okay, that's the molar mass, right? You see grams per mole? What's the molecular mass? Molecular mass. Molar mass is this, in grams per mole. By the way, if you read it in the reader really good, it shows to you there why it's always true. That the molecular mass is exactly the same number, but 36.4, but in what? AMU. Molar mass grams per mole, molecular mass is going to be so many MU per molecule. So HA as a molecule has so many AMU. That's the molecular mass, right? And the molecular mass of this is going to be equal to, molecular mass of this HA is going to be equal to what? 1. Hydrogen is about 1, right? 1 AMU. Plus, how many AMU of HA? One AMU from hydrogen. From hydrogen, you have N1 AMU. Plus, how much of this? We don't know. That is the molecular mass. That's 36.4 AMU. So from this one, you can find out that it's how much? 35 actually. 35.4. And if you look at the periodic table, you know, what is it? It's chlorine, right? So A is actually chlorine. So the acid was HCl, right? See how we did it? Good problem? What do you think? Was it good? All right, let's have some fun. Now, I'm going to make some introduction on here. The pincher, why the pincher does